नमस्ते। चलिए क्वेश्चन नंबर 14 देखते हैं। एक्सरसाइज 9.3 क्वेश्चन नंबर 14। 9.3 in this question number 14 is given the sum of first 5 terms of GP is 16 and the sum of next 5 terms is 128. The sum of first 5 terms of GP AR question number 14. In this it will be given the sum of first 3 term of GP. The sum of first 3 term of GP is given 16. The AR square. This will be given 16. And the sum of next 3 terms is given 128. That is AR cube plus AR to the power 4, AR to the power 5. This will be given 128. This will be given. So this is the first and this will be second equation in this. So this will be given. Now in the second, here from the second we take R cube as a common, so you get AR square. This will be 128. So divide equation 2. Divide this 2. Divide 2 by 1. Divide equation 2 by 1. We get, divide equation 2 by 1, we get what? Divide this equation 2 by 1, you get this will be R cube equal to 128 by 16. This will be 8. So this implies that R equal to 2. So now we get R equal to 2 from equation 1. From equation 1, write the value of R, that is the 2. R equal to 2. So we write the A plus 2A plus 4A. This will be equal to 16. That is 7A. This will be equal to 16. A equal to 16 by 7. Find the sum of n terms. Find the sum of n terms of the geometric series. Determine the first term and the common ratio and the sum of n terms of the GP. The first term is 16 by 7 and the common ratio is 2. Find the sum of n terms of GP. The sum of n terms of GP r to the power n minus 1 by r minus 1. Write the value. A is 16 by 7. R is 2. So that is 2 to the power n minus 1. 2 minus 1, that is a 1. So this is the sum of n terms. The sum of n terms of a GP is this. So now next, let us see the question number 18 of this exercise. Find the sum of the series 8. Find the sum of the series 8 plus 8 plus 8 plus 8 and so on up to the end term. To find the sum of this series Sn, now take the common. Here you take common 8 by 9, then you can write 9 9 9 9 9 9 9 9 9 9 9 9 9 and so on to n terms. Now you get in this n terms. To find the sum, we can write 8 by 9 in place of 9. In place of 9, we can write what? 10 minus 1 plus 10 square minus 1 plus 10 cube minus 1 and so on to n terms. We can write this 8 by 9, 10 plus 10 square, 10 cube to n terms and minus 1 plus 1 plus 1 to n terms. We can write in this way. Take. And now the first series is what? This is in the geometrical series, so that 8 by 9 Sn E is what? 10. Or common ratio is 10. The 10 to the power n minus 1 upon r minus 1, 10 minus 1, that is the 9, and 1 plus 1 plus 1 up to n terms. The 1 plus 1 plus 1 up to n terms, that is the n. So this will be the sum of the series up to the n terms. So this is the sum of the series in this way. So you can find the sum of the series in this way. Okay? So now let us see in this question number next question we see Next question is 23. In this question is given 23. In this question is given if the first term and the nth term of a GP is A and the B. The first term and nth term of a GP is given. The first term is given A and nth term of a GP is given B. The first term and nth term of a GP is given A and B. Then prove that nth term of a GP A and B respect, and if P is the product of n term, P is given product of n term, then prove that P is the product of n terms. Prove that P square equal to AB. Prove that P square equal to AB to the power n. So now you prove this. So prove that product of n terms. P is the product of n terms. So P is given product of n terms AR square and so on, product of AR n minus 1. So P is the product of n terms. Here now we see A into A into A into A n times. So therefore this will be A to the power n, and R, product of R, so this is 1 plus 2 plus 3 and so on, n minus 1. The n minus 1, this will be the arithmetical progression. So you know that arithmetical progression, the sum of arithmetical progression. Now you get this A to the power n, R to the power n minus 1 n. Sum of the first n natural number, you know that n plus 1 by 2. The n minus 1 n by 2 in this way. So you can write this what? A to the power n, and here you can write here R to the power n minus 1 n by 2. This is the P. Squaring both sides, P square, so then you get what? A to the power 2n, and you get A to the power 2n, R to the power n minus 1, and you get this. So we can write this what? A to the power n, A to the power n, and A r to the power n minus 1 and e to the power n and n, and in this way. So now you can write this. We can write this a to the power n and ar to the power n minus 1 whole to the power n. So this will be the b. So we can write this a to the power n and b to the power n, where it will be given b equal to ar to the power n minus 1. This will be given. The nth term is the b. The nth term is the b, it means that what? The nth term is the b, it means that ar to the power n minus 1, this will be equal to b. So that we can write ab to the power n. Hence p square equal to ab to the power n. This will be proved. So this will be proved. So this proved the theorem. So this proved the theorem. Now let us see the next question. Now let us see the next question, question number 25 of exercise 9.3. If A, B, C, D are in GP, if A, B, C, D are in GP, if A, B, C, D are in GP, then prove that what? A square plus B square plus C square plus and B square plus C square plus D square equal to AB plus BC plus CD, AB plus BC plus CD whole square. So now prove this. Since ABCD are in GP, since A, B, C, D are in GP, therefore A, B equal to AR. Here is the, we see here, if A is the first term, we write if A is the first term and R is the common ratio, the B is the AR, C is the AR square and D is the AR cube. D is the AR cube. So then we show that this will be equal to this. So now from this left hand side, see the left hand side, in the place of A, write the A square. In the place of B, write the AR square. In the place of C, in the place of B, write the A square R square. In the place of A square. The A square, write the A square. In the place of B, A square R square. In the place of C, write the A square R to the power 4 in this. And in the place of B, to write the A square R square. In the place of B square, C square, A square R to the power 4, and D square, A square R to the power 6 in this way. Here you can write this. So now in this you can take the common A square to get 1 plus R square plus R to the power 4, and here you take the common A square R square to get 1 plus R square plus R to the power 4. So now from this we can write A to the power 4 R square, and here you can write 1 plus R square R to the power 4 whole square. In this way, so we can write this in this way. From left hand side we can write this. Now in the right hand side, now let us see the right hand side. Write the value in the right hand side. AB plus BC plus CD whole square. So write the value of in this. Write the value of A and B. The A is A and B is AR. So this is the A square R. A square R AB plus BC. Write the BC, the A square R cube. A square R cube. This is the BC, and CD, the A square R to the power CD, the A square R to the power 5. So you write A square R to the power 5. The A square R to the power 5. So now in the place of BC A square R to the power 3, A square R to the power 3, CD A square R to the power 5, AB A square R. In this way, that is the whole square. Take the common A square R, so we get what? we get a to the power 4 r square. The square take the common 1. There you get a r square, and here you get r to the power 4 whole square. So this will be so that what? From these two, from E1 and 2. So from 1 and 2, from 1 and 2, from 1 and 2, what happened? From 1 and 2, left hand side equal to right hand side. So this proves the theorem. Left hand side is equal to right hand side. So this one. So now let us see next question. Question number 28. In this question, it will be given the sum of two numbers is 6 times their geometric mean. The sum of two numbers is 6 times their geometric mean. Let the numbers are a and b. Let the numbers are a and b. The sum of two numbers is 6 times their geometric mean. Geometric mean of these two numbers is root AB. Then we can write a plus b by 2 root AB equal to 3 by 1. We can write this then by componendo and dividendo. By C and D. By componendo and dividendo, we can write a plus b 2 root AB upon a plus b minus 2 root AB. That will be equal to 3 plus 1 and 3 minus 1. The 3 plus 1 and 3 minus 1. We can write this. So now this will be implied that what? We can write root A plus root B whole square upon root A minus root B whole square equal to 4 upon 2. So this is the 4 upon 2. So this will be 4 upon 2. So that is the 4 upon 2. We can simplify this 2 by 1. You can write this 2 by 1. You can take the root of this. The root of this we can take. Here is the root A plus root B upon root A minus root B equal to root 2 by 1. So now here from we get by again componendo and dividendo by C and D. By componendo and dividendo we can write here root A plus root B, root A minus root B upon root A plus root B minus root A plus root B in this way. Now here you can write root 2 plus 1 root 2 minus 1. So this will be what? B and B is cancelled. A is A and cancel. You get 2 root A upon 2 root B. This will be equal to root 2 plus 1 upon root 2 minus 1. Root 2 minus 1. 2 cancel and the squaring this. You get A by B. The squaring this is 2 plus 2 root 2 plus 1 upon 2 minus 2 root 2 plus 1. Therefore, A by B equal to 3 plus 2 root 2 upon 3 minus 2 root 2. The ratios of the two numbers are in this. So now you prove A ratio B equal to 3 plus 2 root 2 upon 3 minus 2 root 2. The A ratio B is what? 2 plus 2, 2 plus 2 root 2 and 2 minus 2 root 2. Okay. The A ratio B is this. Take. The A ratio B is this. Now let us see the question number 29. Let us see the question number 29. In this question, it will be given if A and G be arithmetic mean and geometric mean respectively between two positive numbers. Prove that the numbers are A and G. A is the arithmetic mean and G is the geometric mean between two numbers two numbers A and B. The A and G is the arithmetic mean and geometric mean between the two numbers A and B. Then prove that geometric mean between two positive numbers. Prove that numbers are. To prove that what? Prove that the numbers are. Prove that the numbers are minus A, plus minus, under root, plus minus, under root A plus G and A minus G. Prove that the numbers are. Prove that the numbers are this. A and B are this. The numbers are this. So now in this arithmetic means, A is the arithmetic means of two numbers. It means that it will be given A is the arithmetic means of two numbers. A is what? Arithmetic mean of two numbers. It means that A plus B equal to 2. And G is the geometric mean. The G is the under root AB. It will be given. Therefore, sum of two numbers A plus B is 2A, and product of two numbers AB equal to G square. So you know that if the sum of two numbers, sum of two positive numbers, and the product of two positive numbers, if the sum of two numbers and the product of two positive numbers are given, then what? Then you can write the quadratic equation. So you know that how you write the quadratic equations. If the sum of roots and the product of roots are given, then you can write the quadratic equations. Hence, the sum of roots and the product of two roots means positive numbers are given, then you can write the quadratic equation. The quadratic equation is what? X square minus sum of the roots. The sum of the roots is given A plus B, that is 2AX, plus product of roots AB is given, that is the G square. X square minus sum of the roots plus product of the roots. So then you can write G square, that will be equal to 0. So this will be given. So now from this quadratic equation you can find the roots. So you can find the roots of the quadratic equation. X equal to minus B. So you know that this is the X equal to minus B plus minus under root B square under root B square. B square is what? 2A. The 2A is what? That is 4A square. 4A square B square minus 4AC. The 4A. A is what? 1 and C is G square. That is 4 G square upon what? 2A. In the place of B, here is in the place of B, there is the 2A. 2a, this is negative, the minus minus plus. So this will be 2a. We write only 2a. 2a plus minus b. So here you write 2a minus b. The minus b minus x square minus x square minus sum of the roots plus product of the roots. There you write minus b plus minus under root b square minus 4ac upon 2a. So that is the 2. So this is the minus b plus minus b square minus 4ac upon 2a. The two positive number, sum of the roots. So you can write x square minus x square minus sum of the roots. So that is the 2e, this one. Sum of the roots, so that is 2e. So you can write in this. Okay? So this is the quadratic equation. Now in this minus 2a, we can take the common. So this will be what? 2, and here you get a, you can get, here you can get what? Under root a plus g and a minus g upon 2. Take 2 as common and we cancel this, so we get minus a plus minus under root a plus g and a minus g, and 2 is 2 cancel. So now we get this. Hence this. So now we get the two positive numbers are A and B. Two positive numbers A and B are what? Minus a plus minus under root a plus g and a minus g. So this will be the answer. Thank you.